Alright, welcome back. This is the Chemistry Girl, and we are picking up where we left off. So, if you haven't watched the video about Introduction to Chemical Equations, and this looks unfamiliar to you, you may want to go back and watch that first. But this is where we left off. We said magnesium metal burns in air to produce magnesium oxide. We went ahead and we wrote out this thing, which we call a chemical equation. The chemical equation is a symbolic representation of the chemical change. And then down below, you'll see my particle diagram representation, the magnesium being red dots and the oxygen atoms being blue dots. Okay, so I just want to remind you that over here, and maybe I'll use orange, over here we have the reactants. And over here, we have the products. In this case, only one product. But sometimes you'll have more than one product. And so, what we said before is that the reactants were the things that were before the chemical change takes place. And the products were the things that were left over after the reaction is complete. And so then here in the middle, where the arrow is this dividing line. And we've talked previously about this thing called, and I'm going to write this off to the side, the law of conservation of mass. And the law of conservation of mass states that the number and types of atoms before a change takes place must equal the number and types of atoms after the change is complete. So we see here there's a problem, because if we just take a look at the magnesiums, we see there's one magnesium before and there's one magnesium atom after, which obeys the law of conservation of mass. Okay? However, what we see is that there are two oxygen atoms present before, but only one oxygen atom present after. And so the question is, where did the other oxygen atom go? And so that is what I want to talk about today. How do we balance chemical equations? Because in order to obey the law of conservation of mass, we're going to have to balance this equation. And so at this point, I need to talk about things called subscripts and coefficients. And so, because we've talked about subscripts first, I'm going to go ahead and focus on that. So this number here is called a subscript. And it tells me how many atoms are bonded together to make a molecule. Okay? The key word here being bonded together and atoms. Atoms bonded together. And so we see in this case, I drew two oxygen atoms and I drew them actually connected or bonding together because the subscript is telling me they need to be bonded together. In this case, you notice I don't say Mg2, and you also notice I don't say MgO2. Okay, I don't add a 2 there. And the reason I don't do that is because, as we've discussed previously, the magnesium has a charge of positive 2 and the oxygen has a charge of negative 2. And because I want these charges to cancel out when I combine them together, and in this case they do, I only need one of each. And so we could think that there's an implied subscript, so there are these implied ones, which would represent the subscripts of Mg and O. And so I draw one Mg and one O bonded together, except conventionally we don't write the ones. So if the subscript is 1, we actually don't write the ones. And so I'm going to leave them off, but I just want you to know that there are implied ones right next to the magnesium and next to the oxygen. And that's telling me that I have one magnesium and one oxygen bonded together. And so the other thing I want to make a comment about subscripts is that they are used to show diatomic elements and balance charges. So what we just talked about is that this oxygen is a diatomic element, and so to show that, I write a little 2 or a subscript of 2. We also said the way we figured out the subscripts for this magnesium oxide was by balancing these charges. Okay, so we're using the subscripts to show diatomic elements and to balance charges. So in order to come back to this law of conservation of mass, what we cannot do is we cannot put a 2 there. We cannot change the subscripts, okay? Because if I did that, then what would happen is another oxygen would be added on the other side because the subscript tells me that these are bonded together. And then I would see that the magnesium is positive 2 and each of the oxygens is negative 2. And when I add up all of these positives and negatives, I do not get 0. And that cannot happen. And so what I have to do is I cannot change the subscripts. So I have to leave it this way. So for the law of conservation of mass, do not change subscripts. Instead, what we are going to do instead is something different. We need more O's over here. We need more blue dots. And so what I'm going to do is I'm going to draw an entire extra compound or molecule of MgO, and it's going to be bonded together. Oops, it's bonded together. So here's another MgO molecule. And because I have 2 of them, I'm going to put, I'll do this in orange, I'm going to put a 2 out here in front. And then you may say, well, that fixes the oxygens. Now I have 2 oxygens on the right and 2 oxygens on the left. But now I've messed up my magnesiums. I have 2 magnesiums on the right and 1 magnesium on the left. So now I'm going to go over here. I'm going to draw another magnesium. And because I did that, I'm going to put a 2 out in front of this magnesium. And when I draw these bigger numbers out in front of the molecule or the atom, I'll use purple, I call that number a coefficient. I call that number a coefficient. And coefficients are different than subscripts. Let me get myself a little bit more space here so I have more space to write. Just a little bit more space. Okay, so the coefficient, we use the coefficient to obey the law of conservation of mass. The coefficient tells me how many reactants or products are in the chemical equation. And the key idea is about the coefficient is that these things are not bonded together. They are not bonded. So you notice that this 2 here means I have 2 separate magnesiums. These magnesiums are not bonded together. So I'm going to take that away. They are not bonded together. They are separate. In the same way that I put a 2 out front here, that means that these things, they are not bonded together. Okay? They are two separate things. Oops. Okay? So to show that I have 2 magnesium, I put 2 separate dots. And to show I have 2 magnesium oxide, I draw 2 separate molecules altogether. And then when I go back and count, I have 2 magnesiums on the left, I have 2 magnesiums on the right, I have 2 oxygens on the left, and I have 2 oxygens on the right. And so now we would call this a balanced chemical equation.